Okay, so this is the fourth problem. We have this diagram. The circle has center O and the radius is 400 meters. And points A, B, C, D lie on the circle. Angle AOB is 1.6 radians. Find the length of the chord. Well, if I redraw this triangle, I know that any point from the center to the edge of the circle is a radius, so all of these are both 400. And we know that this is 1.6, so to find the length of this chord is simple because we have two sides and an angle in between. And as you can remember, that is going to be the law of cosine. So we're using the law of cosine. So let's go back. We have our c squared, our missing side, is equal to 400 squared plus 400 squared, the two legs squared added together, minus 2 times the two legs, 400 times 400 times the cosine of the angle. Sorry, red eye row. Cosine of 1.6. All right, so I put that all in the calculator and I take the square root. I'm going to do it in one fell swoop so you don't make any mistakes. 400 squared plus 400 squared plus 2 times, minus, got a little happy. Okay, let me fix that. 400 squared minus 2 times 400 times 400 times cosine of 1.6. And I put all of that into my handy dandy calculator. Therefore, I won't make any mistakes by putting all that just straight into the calculator. Okay, so it's a total of 573.884. C equals 573.884. And so if I round that to the appropriate significant figures, it should be 573.9 meters. Find the area of the triangle AOB. Well, the area is simple to find because we have 1/2. The area of a triangle is 1/2 A, which is 400, times 400 times sine of 1.6. And I just put all of that into my calculator too. Alrighty. So 400 times 400 times sine of 1.6 is 79,965.9. And that's going to be meters squared. And then it says find angle BOC. I'm sorry, angle BOC is 2.5 radians. So 2.5 radians. And the length of ADC. So here's the length, ADC. Find the length of that arc, which is, in order to find the length of that arc, I need to find this angle first. Or another way I could do is find the length of this arc and subtract it from the circumference, whichever one is fine. So, but in order to find the length of the arc, I know that this whole circle is 2 pi. And so I say 2 pi minus the first angle of 1.6 minus the second angle of 2.5, and that's going to give me my third angle. So I simply subtract 2 times pi minus 1.6 minus 2.5 is going to give me 2.18. 2.18 or 2.2. 2.18, 2.2. So put that in there. We know the length of an arc is equal to the radius times the angle, theta. So 400 times 2.2 is 180 meters. So it's 180 meters. Okay. And then it says find the area of the shaded region. So that would be the area of the first sector plus the area of the triangle, which we already found the area of the triangle to be 79,965.9. So let's find the area of that sector. So remember, the area of a sector is 1/2 times the radius squared times theta. So, and remember that formula comes from right here, area of a sector. Okay. So 1/2. The radius is 400 squared times 2.2. So that is 176,000. And again, I add these two together. Which is 255,965.9, and that's meters squared. And the last part says that the shaded region is to be planted with corn. Corn seeds are sold in bags, which cost $140 each. One bag is enough to seed 8,960 meters squared. How much does it cost to buy the corn seed? So this is a simple problem. One bag will cover 8,960. So we have to divide to see how many bags we need. 8,960, we're going to divide that to see how many bags we need. So we need a total of 28.56, but remember we can't buy 0.56 of a bag, so we have to round that up. We need a total of 29 bags. Each bag costs $140, so we have to say 29 times $140, which is 4,060. So we need a total of $4,060. All right, and that's it.